Right. Peter, I've sent a link to you now for the YouTube.
Can you hear me, David? I have the YouTube here. Thank you, David. I've just wondered, is this so that I can hear questions that are asked at the end? Is the necessity for me to have the YouTube channel so that I can hear questions at the end? Right. Understood. Well, I have it here on YouTube, so hopefully that will work.
Peter, can you hear me?
Yes.
Okay. I think what we're going to have to do is just do a stream. I'm going to kill the microphones here, and then you're just going to have to do a stream of consciousness because it's not wanting to play.
Okay. Just let me know when to begin.
Right. Is Andrew there? Andrew, because yeah. That's there for the truth. You introduce them, and then.
Okay, sorry about that. The other thing, just to mention, is unfortunately Anglo pulled out. So despite the fact we're starting this one a bit late, everything will run to time. So fear not. So after wangling the technical things, hopefully Peter can start.
Yes.
Yes.
Peter, would you like to go ahead?
Yeah, can you hear me okay? Fantastic.
A bit louder.
Can you hear me okay, Neil?
Yes.
Try again, Peter.
Right. Can you hear me okay?
Yeah.
Fantastic. Well, thank you very much. And thank you, David and the team, for facilitating this virtual presentation with you. I'm pleased to be able to be here this afternoon. Right, well, by way of an introduction, I am a practicing fire engineer, a fire risk assessor, and I actually presented to the Mining Institute, presented one of your monthly lectures a couple of years ago, as I was ending my year as international president of the Institution of Fire Engineers. But today, as part of your engineering safety session, I want to reflect on the fact that every day, buildings or engineered structures collapse and there are deadly fires. Every day, there is news of more damage to our countries from the climate emergency. Such events cause devastation in their communities and can have widespread impacts for both those that are victims and those who are involved in the design or construction or management of the facilities affected. As engineers, we have the ability to control the safety of structures and to influence the effects of climate change, so that we must have a concern about what we do and take more care for the benefit of the community and ourselves. Now, a balance always has to be struck between ethical behaviour and the drivers for financial gain, often a paramount consideration amongst those who employ us. But what we really ought to be doing is to learn from failures and to make change happen. So I would like to take a small amount of this presentation to bring us all up to speed with CROSS. It's an abbreviation. It stands for Collaborative Reporting for Safer Structures. And our roots go back to 1976, when the Standing Committee on Structural Safety was established in the UK by the presidents of the Institution of Structural Engineers and the Institution of Civil Engineers. These institutions agreed to fund and set the strategy for what was known as SCOSS at the time, with its main function being to identify in advance trends and developments which might contribute to an increased risk to structural safety. And this was a direct response to several box girder bridge collapses, and also to Ronan Point, which was a 22-storey tower block in East London that partly collapsed on May the 16th, 1968, only 2 months after it had opened. And a gas explosion blew out some load-bearing walls, causing the collapse of one entire corner of the building. Sadly, 4 people died and 17 were injured. In 1995, the Health and Safety Executive joined iStructD and ICE in funding and setting the strategy for CROSS. The next big milestone was the implementation in 2005, that's right, 20 years ago this year, of a system for the collation of data on matters of concern relating to structural safety. And that's when CROSS was officially born. And CROSS, I'll talk more about the system in a minute, but it's based on a scheme that originally came from the aviation sector in the United States. It's an aviation sector reporting system, ASRS, which was developed by the Federal Aviation Administration and implemented by NASA in the United States, with the key feature of it being entirely confidential. Now, if I fast forward to December 2017, which was just 6 months after the Grenfell Tower fire, Dame Judith Hackett produced her interim report into into the building regulations and fire safety. The themes and the issues that she identified continued through to her final report, all being accepted by the UK government. Dame Judith made a distinct recommendation that CROSS should be extended and strengthened. And in 2020, the UK government provided funding to expand CROSS to cover fire safety in order to fulfil that recommendation in her Hackett report. CROSS began working with the Institution of Fire Engineers to develop and run CROSS for not only structural safety but also fire safety. And in April of 2021, CROSS UK was relaunched to cover both disciplines. Now, we're pleased to say that in July 2025, the Health and Safety Executive, in its role as the Building Safety Regulator, appointed CROSS as the official voluntary reporting system for structural and fire safety until at least 2028. And this was triggered or brought on because of the government's response to the Grenfell Tower fire. The 2022 Building Safety Act introduced strengthened legislation covering building safety and construction products, and it included the requirement for a voluntary occurrence reporting system to be implemented. CROSS was operating on an interim basis until then, and we're delighted that we're now officially the voluntary occurrence reporting system as required by the Building Safety Regulator. We do operate internationally as well. In 2018, CROSS Australasia was launched, and 2019, CROSS US was launched. But both these international jurisdictions are currently operating as structural safety reporting only, not yet including fire safety. But as you can imagine, we very much like that to happen quite soon. And we've also got colleagues in Germany who we're talking to about extending our reach to there. I'm going to quickly talk to you about the process for CROSS, how the process works, and then move on to some significant examples. But I think it's worth taking a bit of time to understand the process. And it follows this wheel, starting at the lighter coloured segment, moving around to the darker. So it all starts off when a report about a safety issue is submitted to us using our secure website. So after somebody submits a report to us, they receive a confirmation email, and then it is only designated people at CROSS who then communicate with the reporter throughout the process of that report being finalised. The first part of the process is the report is anonymised. Designated people do that. I'm one of two designated people who look after the fire safety reports that are submitted to CROSS. And the anonymisation process includes removing all personal information and also any other identifiable details that are included in the report. Once that's done, the anonymisation and de-identification, the report is sent to our expert panels for them to add their comments and knowledge to enhance the learning from that report. The report is then passed on for legal review to make sure there are no concerns before the report is published. And then the final report is sent back to the original reporter for any final comments before the report is published. Our reports are always published on our website first, and then they are often collated in our newsletters and published through other means as well. as part of a dissemination plan. So what are the kind of things that CROSS get involved with? Well, this is a typical risk triangle showing a hierarchy in which the precursors of major events are sort of identified as lesser events and near misses down at the bottom. This is the area in which CROSS operates, hoping to reduce the number of events that would feature at the top of the triangle. And if you think about what happened at Grenfell Tower back in June of 2017, thankfully, for disasters of that magnitude to occur, there has to be a lot of things that go wrong. And it's those things that go wrong, those what could be considered minor events, there where CROSS wants to operate, eliminating those, eliminating the chance for that Swiss cheese model to come together, and all those, the combination of those minor events to create a major event. Reports that are sent in to us from all stakeholders within the built environment typically relate to concerns, near misses, or incidents. We're also interested in weather-related matters as part of a contribution to environmental issues, but we really want to receive reports from all areas of the building life cycle, from design, construction and operation stages, as well as refurbishment, alteration, change of use, extensions and end of life of buildings, demolition. But reports should aim to include information that will help others to learn from those safety issues that are identified. This is a word cloud that shows the key aspects in our ethos. And you can see the kind of things that are mentioned there, that I mean, culture being the a key one there that was identified in Dame Judith Hackett's report, and went on to form the basis of the Building Safety Act. And you'll hear lots of people saying that the construction industry needs to improve its culture. And we're hoping to play a little part in that. I'm a fire engineer. I'm now going to talk a little bit about some of the structural safety reports that we've received, just to give you a flavour before focusing more in depth on fire reports. So, like I say, I'm no expert and don't claim any competence on this, but the top left photograph there shows us some complicated finite element model of a very tall building. The question posed is, where does the load go? Top middle, we've got a crane collapse during construction. Top right, unplanned demolition of large panel structure building because I can only imagine because it wasn't planned. The demolition's gone wrong there, created more problems than it was intended. Bottom left, concrete components are falling from a highway bridge. Bottom center, complex connection held by a single bolt. Single point of failure issues reported to us. Bottom right, collapse in use of a seating platform in a temporary grandstand. I'm sure we can all understand the life safety implications in that structural failure. That gives you a flavour of the range of structural safety issues reported to us. One particular important issue is about reinforced autoclaved aerated concrete panels. So RAC, as it's commonly known, is a construction material that was commonly used in the late 1960s, early 70s. It was always intended to have a limited lifespan within buildings, so 20 to 30 years, and it's a construction product that is particularly vulnerable to ingress of moisture, particularly rainwater, and incidents and concerns were reported to Cross. So much so that Cross produced a safety alert in 2019. But it wasn't until the mid-2020s, if you remember back sort of this kind of time, a couple of years ago, the Education Secretary had to close a number of schools just before students were returning because the issue of school roofs and ceilings collapsing gained significant prominence. Unfortunately, Cross were talking about these issues way before the mid-2020s, because obviously that was an issue that we thought was important. Maybe we need to be banging the drum a bit louder in the future. Right, I'm conscious of time, and I'm going to move on to fire safety reports, because that's what's I think is of most interest today. I'm going to start by giving you a flavour, a snapshot of perhaps a quarter, 3 months worth of reports that we've received, just to give you a flavour of the variety of the items we're dealing with. Fire resistance requirements of flat roof upstands. Fire spread in a staircase which trapped occupants. So the first two there, one is very much a design-based issue, the requirements, performance-based requirements for a particular element in building design. The second is an issue that happened in an occupied building, which then gives us questions around how that building was designed. Concern about the lack of legal requirement for firefighting equipment in residential premises. So that's the provision of fire extinguisher in blocks of flats, maybe, often an issue that gets debated. Sprinkler system deactivated during construction works. That's interesting. It's a report that relates to the refurbishment of a building, and yet the deactivation of a particularly important fire protection measure causes issues for the rest of the building, which is still being occupied. Fires involving thermally modified wood. So thermally modified wood is a treatment process that's used to give a blackened or charred appearance to timber cladding that's often used on the outside of buildings. And we've seen a couple of incidents in buildings that involve that kind of wood, that kind of construction material. So we're asking some more questions about that. Fire resistance for multi-tier storage systems, fire barrier requirements and external wall systems. I'm sure we're all aware that since Grenfell, the external wall systems in buildings have come under great focus. This report digs into one particular aspect of that. Safety concerns as a residential building, fire protection considerations for roof structures, a provision of water for firefighting, failure of a firefighter's lift to operate, really important stuff, fire performance of timber cladding, unventilated void has the potential to fill with natural gas. That was an interesting report that we thought was worthy of pursuit. We identified we didn't actually have gas engineer expertise on our expert panel, so we invited a visiting expert from the Institute of Gas Engineers and Managers to join the panel to particularly help us with that report. Fire protection of timber frames. You can perhaps see a theme that timber comes up time and again in our reports. Inadequate means of escape from temporary sporting venue structures. Assumption about an older building's fire resistance leads to rapid fire spread. Confusion over fire resistance of lintels. I know I've whizzed through those, but it's giving you a sense of the broad spectrum of the reports we receive. And I'm glad to say that we're getting enough reports now to start identifying trends. We have some reports that are giving us similar themes or trends, and these are the reports that we then think we need some intervention on. So effectiveness of third-party certification schemes is something that we're finding a few reports are giving us cause for concern, which is interesting because quite often we always recommend the use of third-party certification schemes to give clients that kind of assurance that the services and the products they are commissioning or procuring have the correct checks and balances in place. But there are some words of wisdom that you need to be aware of in order to make sure that there's no playing the game here, and that you're getting exactly what you're expecting. Fire testing of light gauge steel stud walls is a recurring theme, and we've got an example I'm going to talk about in a moment. Automatic opening vents is another interesting area that I'm going to give a bit more detail about if I've got time. Modular construction as well. We've got concerns about fires in multi-storey car parks, concerns about lithium-ion batteries. And I just want to give you some example of how our safety reports look. They all have this similar layout so that you know exactly what you're getting. We have a nice descriptive title, which is carefully worded to allow for search engine optimization. We have a carefully worded overview that gives you enough detail to know if this is something for you. We have key learning outputs, which are targeted and punchy, and if you only get this far, then you've gained something tangible. We then have the anonymized report that was given to us from the reporter with some editing for clarity, and then we have our expert panel comments, which give a much more detail and give some real depth on the subject. I want to quickly talk about an interesting topic about fires in multi-storey car parks. Liverpool Echo Arena car park fire happened in December 2017. Actually, it was on New Year's Eve. It gutted the 7-storey building. Up to 1,400 cars were destroyed. Fires in car parks are not uncommon. However, the Liverpool fire was unprecedented in scale because unusually the initial fire in one car rapidly spread to other cars. Here's a nice photo showing the car park before the fire. This shows the car park is that rectangular thing in the center. It's closely located to that light grey building there, which is a hotel. To the left of it is a block of flats, and then beneath it is an entertainment venue. So it's wedged between genuine life safety risk there. However, it was designed, as you can see here, with 15 minutes of fire resistance because it was assumed that the car park was open-sided, and this was the guidance that was given in approved document B. So all's okay there, isn't it? Well, maybe not. Here's a couple of images, one during the fire and one after. And you can see that there was significant destruction, so much so that the structural slab disintegrated. You can't walk on that clearly. But Cross was lucky enough to be given access to the site on the 4th of January 2018, accompanied by Merseyside Fire and Rescue Service. And those visits culminated in a safety alert being published. Now, as part of that investigation, clearly you couldn't walk on those slabs, so a drone survey of the interior was commissioned. It was done with a Elios impact-resistant drone surrounded by carbon fibre cage, and we were also on site during the eventual demolition of the structure in February 2019. Right, so we produced a safety alert which gave a lot of information and detail about the fire gave consideration for those who were designing new multi-storey car parks, as well as those who manage existing multi-storey car parks, about how perhaps we should be thinking in a bit more detail about resilience. And in October 2019, Cross publish a report called Fire Resistance of Multi-Storey Car Parks. Now, a reporter came to us stating that they recently visited a constructed car park which contains some of the same design issues as discussed in our alert. They find it difficult to believe that the car park they visited could survive for significantly more than 15 minutes in a fire without collapsing. Well, that's wise words. Another report in October 2020, a reporter is concerned by the reluctance of the industry to voluntarily take on board and proactively react to the lessons learned from the Echo Arena car park fire in Liverpool. We couldn't agree more. And then we have this. I'm sure you remember it. In October 2023, there was a fire in a car park at Luton Airport. It started about 9 p.m. on Tuesday, the 10th of October, and wasn't extinguished until the next day. Flights were closed. The airport was closed to flights for 18 hours. The fire appeared to have been accidental, began as a parked car, a diesel vehicle. Now, the Luton car park was designed and built after the Cross alert was published, and if those involved had read the alert, then the outcome might have been different. Luton structure was a steel frame, clearly different to the concrete frame in Liverpool, but it was badly affected by the fire and had to be demolished. Here are a couple of photos showing that. Now, at the time, we were asked for our comment. You'd be unsurprised that we issued a press statement in the immediate aftermath. We had to stay appropriately neutral and say things like, a full investigation will be required to understand what happened, and we do not yet know the reasons, blah, blah, blah. And when details are available, we'll help disseminate lessons learned so that similar events can be prevented in the future. And we were able to signpost to our previous work on this. And then last April, so April 2024, which was 6 months on from the Luton Airport fire, we published a blog that gave more signposting of the reports that we've received and the advice that we've given. It's a good example of Cross responding to an incident, responding to safety reports received, researching and then publishing a safety alert, and then promoting these resources whenever we can to help prevent a future incident. I know we're really pushed for time. I wonder if I can perhaps give another example. I'm going to continue until you tell me otherwise. We received a report from someone who was concerned that the remediation and replacement of cladding on 2 buildings caused automatic opening vents to be inoperable for months, potentially compromising residents' escape routes in the event of a fire. Okay, then we received this report. Automatic opening vents in a residential block undergoing remediation were compromised by a subcontractor covering them with masking material. And this occurred during the preparation for an application of a final render. Okay, this is interesting. So 2 reports come to us that are very similar in nature. I mean, we all know what AOVs are, don't we? Well, it turns out that not everyone does know what automatic opening vents are. Automatic opening vents are an important part of smoke control systems that are often installed in blocks of flats and other residential buildings. However, unusually, these are items of essential fire safety apparatus that are often disguised by architects because they want their facades to look nice and neat. So this is a picture showing, well, actually it's a block where my parents live, but it's showing windows, and if you look on this middle row, bits, the window that is within the darker grey area, the way you can see there's a safety rail on the inside, that is actually the automatic opening vent on this level. And it's you can see that that is well disguised by the architect. So this is a very important concern, but it's technically quite simple. And the message, it's a simple message, and it's a simple message that needed conveying quickly. We provided a safety alert and promoted it heavily. The alert draws the attention to the safety risk associated with preventing the operation of smoke vents, in particularly automatic opening vents by construction works in existing buildings. And I encourage you to look at those. Now then, I've got the message that we are finishing at 12:35 for this presentation, so I apologise for running over. I was going to draw your attention to lithium-ion batteries to a safety alert, a topic paper that we've published on that. I was also going to talk a bit about cross-laminated timber, but in order to get back onto time, I just want to make sure that everybody in the room and everybody watching on YouTube knows about Cross, has the opportunity to benefit from the information we provide. So please sign up and become consumers of Cross material. And then I would like to encourage you to contribute to this body of knowledge by sharing with us safety concerns that you find in your everyday work as engineers operating in the built environment. It's really easy to do. It is genuinely a confidential service, but it is really important to do that so that others can benefit from the concerns you've identified, so that others can avoid those pitfalls in the future. I think I've run over a little bit, but I'm going to end there. I'm going to stop sharing, and hopefully if there's any questions, I'll be able to hear them. Thank you.